Hi, my IB physicists. This is a video for you if you are feeling like, gee, Ms. Gatz, what are vectors? I don't know. I have no idea. This might particularly pertain to you if you were, let's say, absent on Monday for class when we went over vectors. So we're going to talk a little bit about what vectors are, just a brief review. And I'm going to do that the old-fashioned way so I don't have to look at a screen, and it's going to make me so happy not to look at a screen. So let's figure out, before we try to do our homework, what are vectors? So what are vectors? That's our whole goal today. We're going to try to figure that out. We're going to see if, yeah, it looks like it's recording fine. So a vector is a measurement that has measurement with both a magnitude and a direction. We'll do that in a fancy color as well. Direction. So direction is a word you probably already know. It just means like, you know, where. Towards where. So a direction means where. A magnitude means size. So it's the number part of a number. So a vector is a measurement that has both a magnitude and a direction. An example of a vector would be 7 meters per second east. Notice it has a magnitude, number part. It has a direction part. And I will just throw this marker out. Whee! Or another example would be 35 newtons at 300 degrees. So again, magnitude, direction. So that's a vector, and vectors are really useful numbers, and we're going to be actually doing a lot with them. That's what our assignment's about. To contrast the idea of a vector, there's also something called a scalar, and that's a measurement. Yeah, that's spelled right, with only a magnitude. So that's a measurement that doesn't have any direction attached to it. So an example of a scalar would be like 3 kilograms. Masses don't have directions. It's just a number. It's a measurement that only has a magnitude. We also might say 7 meters per second. This is a speed. It lacks the direction part that could make it into a vector. So we have vectors, we have scalars, and we need to be able to add them together. So let's sort of look at what that entails. Entails is actually a special joke because the key thing about vectors is that when we draw them, they have, oh, I bet that doesn't show up that well. Yeah, let's use a different color. How about real green? So when we draw a vector, it has a tip at the beginning. That's where we start. And a tail, that's the pointy part. And that's where, Ms. Gatz, you're just dead wrong. Like dead wrong. Boy, I hope I didn't say this in class. Wouldn't that be embarrassing if I said it dead wrong in class? Also, I spelled tail wrong. I know. So it has a tip. That's the pointy part. Pointy. Duh, that makes sense. And then it has a tail. I'll spell tail right, maybe. Is that how you spell tail? I don't know. It has lost all meaning for me. And that's where we start. And so notice that this vector starts right here, and then it goes over 2 boxes and up 3 boxes to get to its tip. So I can describe this vector as over 2, up 3. So anytime I want to redraw this vector, let's call this vector z, just for kicks and giggles. Anytime I want to redraw z, I know that I'm going to start at one spot, go over 2, up 3, and that's where the tip will be, the pointy part, and then the tail is where I started. It was down here. So this is vector z drawn again. So we can add vectors together, and it's actually pretty logical adding vectors together. Let's draw another vector here on our paper. We'll call it vector, how about vector, ooh, look how long it is. So this vector, we'll call vector, planning, y. That's very logical. And so notice that this vector is very long. It is 1, 2, 3, 4, 5, 6, 7. 7 boxes long. And so its magnitude is 7. Magnitude. We could figure out the magnitude of vector z. We'll do that eventually, but we're not doing that right now. I just want to notice that vector y is 7 long. And so that means I would describe it as over 0 and down 7. So over 0, down 7, that's vector y. So what I can do is actually add together z plus y. And I'll get a new vector. And I'm going to do this with the tip to tail method. So that means I'm going to start by redrawing vector z. So vector z, you're right here, over 2, up 3, whee. Here's z. Here is z's tail, then its tip. And then on the tip of z, we're going to put the tail of y. So it's tip to tail. So this is the tail of y. And I kind of like to think of this as just essentially that I'm tracing out a path. 1, 2, 3, 4, 5, 6, 7. I am tracing out a path with arrows. That's all vector addition really is. We're tracing out a path with arrows. We started here. We ended here. So it's kind of like we took a little walk up and then walked down, and this is where we ended up. So I want to show that these two vectors added together equals a path that goes from here to here. So I'm going to draw a vector showing that path. We started here, we ended here, and this I'm going to call vector r. And I'm calling it r because the answer for adding two vectors together is called the resultant. So it's the resultant. And notice that I've labeled it carefully. Notice that I've drawn z carefully to be exactly the same as I had defined z. I've drawn y carefully to be exactly the same as y is defined. And so, ooh, freaky. We have this tip to tail vector addition method. This method can also be called the parallelogram method, where I could have drawn this in a different order. I could have done first step y, that's not y's color. This, if you're like, Ms. Getz, this makes sense to me, then stop listening to me. If you're still a little confused, you can also draw it as a parallelogram. 1, 2, 3, 4, 5, 6. So I'm drawing these in dotted lines so that you see it's a little bit different. So here, again, 2, 3, dot, 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 dot. Notice that there's this parallelogram with z and y. And it doesn't actually matter which order I add them in. So just like normal addition of normal numbers, the order you add them in does not matter. I think that's the commutative theorem, but I don't remember because math class was a long time ago for me. Maybe you do. In either case, no matter what order I add them in, whether I do z first or y first, I still get the same answer, the resultant. Whew, okay, so let's try a couple of these together. I'll help you out with your homework on maybe 2 or 3 together. And let's color code because color coding is just super helpful. So let's do this first one where we have a plus b equals r1. So again, I'm going to draw vector A. I'm going to notice vector A is 1, 2, 3, 4 boxes long. So I'm just going to jot that down so that in the future I don't have to count it out again. And vector B, oof, vector B is 1, 2, 3, 4, 5, 6, 7, 8. 8 by 1, 2, 3, 4, 5, 6. 6. Great. Okay. So I know how big A is, I know how big B is, and now I'm going to redraw them, adding them together. So I'm going to put that down here because I'm left-handed, and if I put it over here, then I'll like cover up the other ones. So first, I'm going to go ahead and I'm going to redraw vector A. So vector A is going to start here, and it goes down 4. So 4 boxes down. Here is A. Yay! Then I'm going to put in B. Vector B is over 8, then up 6 boxes. So that means that to draw vector B, I'm going to start where vector A left off. We're tracing out the path. First we do A, then we do B. So we're starting here now, and I have to go over 8. So that'll be 2, 4, 6, 8. And then I have to go up 6. 2, 4, 6. So this is where vector B will end. That's the end of B, and here's what B looks like. If you want to use a ruler to make it look prettier, you know, that's cool. You can. So I have A, then B, and then I'm going to draw the resultant. I'm going to draw that in red just to make it really clear. So we started here, we ended here, and that means that our resultant, R1, points in that direction. So I have A plus B. Okay, cool. Not so bad, right? Let's try one more easy one together. So that was pink. We'll do it in another color. I'll see if orange shows up. Orange show up in the picture? Yay! So let's try this other easy one. So we're gonna do B plus C. So B plus C. So I know about B already. C is down here, and it looks like it goes 1, 2, 3, 4, 5 boxes. So it's 5 long, and it goes backwards or to the left. So I'm going to do B plus C. So that means first I'm going to draw B. I'm going to make my life easier by having B start right here, and I can tell from the picture above that it goes to that box. So that's an okay drawing of B. So here's B. Whee! I did B. Now I need to plus C onto it. So we started here, we've ended up at this location. So that's where I'm going to add C onto it. So C goes to the left 5 places. 1, 2, 3, 4, 5. Ends up right there. And this is vector C. So then I'm going to go ahead and draw in the resultant. It goes from our starting place to our ending place. Whee! Here is R2. Go team. Okay, that's not so bad, right? And so we can just keep on doing that. E plus D, right? We have some addition of multiple vectors. That means that instead, so we draw A, then we draw B, and then if we're adding on D as in R7, we just continue on here with D, and we just add it onto the tip of B. So we just keep drawing them like a big path telling us first we do this, then we do this, then we do this, then we do this, then we do this, and so on. But you might notice that I have one here that is like a little scary looking. I'm going to skip over R3. You can do that on your own. Pause the video now if you want to try doing it on your own right now. And I'm going to try R4. Because look what's happening. In R4, we are A minus B. Scary, right? So B, normal B, points upwards and to the right, over 8, up 6. Minus B is the exact same, it just points in the other direction. So the minus, the opposite of a vector, is the vector that points in the precisely opposite direction. So let's try A minus B. So I already know about A. I know that A is going to be, I'm going to put it down here again so that my left-handedness doesn't cover up the vectors up top. A is down 4 boxes. I'm going to start here. 1, 2, 3, 4. Yay! Here is A. It is 4 boxes. Then minus B is, again, just like B, except it points in the other direction. So we're going to start here and end here. So that means at the tip of A, we ended right here, I'm going to put the beginning of B right there. So it has to go down 6 and back 8, or back 8, down 6. So I'll do it in XY order. It's a little bit easier. So 2, 4, 6, 8, and then 6 down. 1, 3, great. So that means it's going to end right here. Whee! Ooh, that's not a very good looking vector. Maybe you should do it in like not really fat markers when you're doing your problems. Just a suggestion from my experience right now. Awesome, so we have A to B, and that means that our resultant is going to start here, end here, and here is our resultant, R4. Yay! So this is vector addition. It's the graphical means of vector addition. We're doing it in the tip to tail method. And again, you could also call this the parallelogram method. If you want to look for other videos of how to do it on the interwebs, they'll call it either tip to tail or parallelogram. And it's just drawing the vectors. It's really nice to do it on graph paper. If you want to do it on other graph paper to make them a little bit bigger or easier to do, I don't care, it's fine. And then you're gonna go ahead and take a picture of this and upload it here to Schoology. Let me know if you have any questions, and good luck, team.